Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Ainatul Shakina binti Filde. My metric number is AE180080. Now I will present about the introductions of our topic, which is nonlinear equations. A linear equation is a polynomial equation of the first degree in the form of fx equal to ax plus b. The graph linear equation is straight line. An equation fx equal to 0 with degree greater than 1 or less than 1 is called a nonlinear equation. From graphical point of view, a nonlinear equation does not form a straight line. For example, x equal to cos x equal to 3x squared plus 2x plus 1 equal to 0 and 4x cubed plus 3x squared plus 2x plus 1 equal to 0. To solve the root of a nonlinear equation, one has to find the value of x equal to x, then satisfy the fx prime equal to 0. From a graphical point of view, the value of x prime can be obtained from the graph y equal to fx intercepting x exists. By using intermediate value theorem, it can be roughly locate the interval of the root. The numerical method for finding the root of nonlinear equation will be using bisection method, secant method, and Newton-Raphson method. For this question, we only use two methods, which is secant method and Newton-Raphson method.
So the next is I'm going to explain about how to solve the question using the secant method and Newton-Raphson method. So the question asks a trunnion has to be cooled before it is shrink fitted into steel hub. The equation that gives the temperature Tf to which the trunnion has to be cooled to obtain the desired contraction is given by those function, as we can see all this function. So use the secant and Newton-Raphson method of finding roots of equation to find the temperature Tf to which the trunnion has to be cooled. Assume the initial guess of the root of Tf equals to 0 as Tf naught equals to -100. So in this case, we are the question asked to use the secant method and the Newton-Raphson method. So to solve this question, we need to as it is stated that we need to use this formula that equals to 0, and the question didn't provide the interval, so we need to assume that the interval is Tf naught is equal to -100 and Tf1 is equals to -110. Just assume that is the interval, and then in secant method we are using this formula, but it is easier to understand that we use this formula AD minus BC over D minus C. So this is the A, this is the B, this is the B, this is the C, and this is the D. So we put the formula here to know what is the Tf2, and then we get the answer is -129.0779. So we have the Tf2 equation. So we need to continue the equation until it is cannot be changeable. So the new A is this one, the new B is this one, the new C is this one, and the new D is this one. So we put the equation on the AD minus BC over D minus C formula, and then we get the same answer, which is -129.0779. So since the Tf3 and the Tf3 minus Tf2 is 0.0000, is much smaller than iteration 0.0005, So the temperature to which the trunnion has to be cooled is approximately TF3, that equals to negative 129.0779. So this is the final answer for the secant method. So next, for the Newton-Raphson method, we need to use this formula, the equation that has been given, but we need to in Newton-Raphson method, we need to differentiate the equation. So this the equation after it has been differentiated. So for Newton-Raphson method, we are using this formula, which is xi minus to fxi over f inverse xi. So the first iteration is we just need to substitute the function, the tf1 into negative 100, since the initial gas of the root is t naught is negative 100. So we substitute the formula is each tf into negative 100, and then we just put it into the question, into the formula, and then we get the tf1 is negative 128.06. So this is the new tf1. Next, we need to search the tf2. Same method too. We need to substitute the tf, the new tf, which is negative 128.06, like this. So after we minus it, then we get the new tf2, which is negative 128.75. So same result. If we need to search the iteration tree, and then we get the same answer, which is negative 128.75. So when we look at the table, after we insert the substitution, we calculate and minus the previous the new tf, then we get the iteration 2 and 3 has the same number of TFI function, TFI answer. So since TF3 minus TF2 is equals to 0.000, smaller than iteration 0.005, so the temperature TF to which the trunnion has to be cooled is approximately TF negative 128.75. I know it is a different answer, slightly different answer from the secant method, between secant method and the Newton-Raphson method, but the final answer is merely the same. So that is the solution.
Assalamualaikum and I, my name is Muhammad bin Rafi. So I was assigned by my groupmate to complete the project simulation, and now I will discuss and explain how I do the simulation. So this secant method coding will solve the secant method problem. So I make this coding from this equation. So FTF. Then I put it and consider it as F in this coding. So for the initial value, negative 100 and negative 110, I put it and label it as X1 and X2. So if we run the coding, the root will be negative 128.7449. Actually, the final answer is negative 129.70779. It's quite different, simulation and the manual calculation, but this is the reason why it's happened. So if you look at the workspace, this coding calculate the x1 as negative 128.7549, but for the manual calculation, it get negative 129.0049, and both x1 and x2 has same value for the manual calculation, and it same goes to the simulation, which is negative 128.7549. So in this case, both answer is not wrong, because if we look at the Newton-Raphson method, it come out with the same answer. So that's why we have two method to use it and solve the problem. So for the Newton-Raphson method, I come up this coding from this question. So the question has this function, and I come up this f prime function from the derivative of this function. Then I put both of the function and label it as g and f and g. G is the derivative of this function. So if we run this coding, first it asks to put the number of decimal places. Let's say we put 2. Then it asks to enter the initial approximation. So for this question, the initial approximation is negative 100. So we put negative 100 here, and boom, this is the final answer for this question. So I want to talk about the iteration. So it says that it has 3 number of iterations, which is, I think it's true, because from this manual calculation, it has 3 iteration: iteration 1, iteration 2, and iteration 3. So and the root is negative 128.75, and yes, the root is negative 128.75.
So for the discussion, we see that the secant method is a popular and powerful algorithm for finding the root of an equation. The method has several advantages over the Newton-Raphson approach, as the secant method doesn't require the function derivative and is less prone to erratic swing between iteration. However, the secant method struggles compared to Newton-Raphson regarding iteration required. Most implementation of root finding algorithm is the most commonly used statistically packages use a combination of Newton-Raphson and the secant method to find the equation. So the conclusion is, based on our analysis result, we now conclude that among two methods, secant method is most effective. Newton-Raphson method is converged quicker than other two methods, but require 2 function evaluation per iteration. Secant method requires only a single function evaluation per iteration. Moreover, secant method is more difficult to solve compared and take more times to complete the calculation compared to Newton-Raphson method to solve. Although the solution for both methods are slightly different, but the final answer to both methods are merely the same. So that's all. Thank you.